In this segment, we're going to be talking about making constructions of geometric shapes, and we're going to start off with talking about how to make a perpendicular line segment. So I'm going to start off with a horizontal-ish, more or less horizontal line, and a horizontal line goes on in both directions forever and ever. If I wanted to make a horizontal line segment, then I would just make a piece that starts and ends someplace. It doesn't go on and on forever, but we're going to be talking about our starting points here with our horizontal line, so we'll start with that. And now you're going to be using a compass probably, and I don't have a compass, but what a compass does do is it allows you to make circles. And so I'm going to bring these points just a little bit closer together. And so I'm going to take my compass, I'm going to put my pointy end of my compass here, and I'm going to extend it out so that it crosses over this other point over here. I'm going to do the same thing again, except I'm going to put the pointy end over in the center of this one on the right hand side. I'm going to draw a circle so it goes over to the right hand side and ends at the same point that that one started at before. And so now I have two circles, both with a radius or radii that are the same. Now notice what happens up here. I get a crossover up at the top, so I'm going to put a dot at that point where the two cross over, and it turns red, so I know that they're both crossing over. And down here the same thing happens. Down at the very bottom down here, I get the same thing happening. So now I've kind of used my circles up, so I'm going to just hide those for now. And so I'm left with this. Now if I take my drawing tool, or you're going to use a ruler, and you connect the two lines, what I've done now is I've created a line segment that is perpendicular, which makes a 90-degree angle to this line right here that we've done. So I'm just going to put a point here, and then I'm going to have the computer calculate for me so I can see if it is indeed 90 degrees. So I've gone to my measuring tool, I've gone from point A to point B to point C, and I've asked it to measure it. So there's my measurement of angle, that's the symbol for an angle, A to B to C, and when you name an angle you need to have three measurements, or three letters: starting point, the corner or the vertex, and the ending point. And that's 90 degrees. Now the cool thing that this program allows me to do is it allows me to show you that if I was to change the size of this, it wouldn't make any difference. I'm still going to keep it at 90 degrees, and it doesn't matter if I spin it around, this still works. And if I tell the computer program to show all the things that I hid, which are my circles, and I go to my points, I can see that my circles get smaller because they're just the distance between the 2 points. And those intersection points up here at point A and this point down here at the bottom are going to stay relative to one another. So that's how you make a perpendicular line, or a perpendicular line segment. So I'm going to leave that on there. My perpendicular line segment from here all the way down is my perpendicular line segment. Now I want to make a perpendicular line segment bisector. And so I want to leave this picture on there because once we've made our perpendicular line segment, so this is 90 degrees, A, B, C is 90 degrees, I want you to see that I'm automatically bisected, which means cut it into two pieces to bisect, into a piece here to the B and from B to C. So I'm just going to label these so it's a little easier to talk about. So the distance from D to B should be the same as the distance from B to C. I'm going to get the computer to calculate that for us. And so there it is. I've hidden my first line so we can see. I've drawn a line from D to B and it measures 1.97. And I've drawn a line segment from B to C, and it also measures 1.97. And if I happen to make it bigger, you can see that it automatically makes this equidistant from D to B and B to C. My 90 degrees still stays. So as soon as I make a perpendicular, I've automatically make a bisector as well. And this will come in really handy in the near future. This next construction is going to be an angle bisector. Now we said bisector means to cut something into two equal pieces. So we're going to cut an angle into two equal measurements, or two equal pieces. So I'm going to start off with my angle, and there it is there. I'll label it now. So we can call that angle ABC. And I'll have the computer measure that for us. and it comes out to measuring 46.64 degrees. If I make it bigger, my angle gets larger. So I'm just going to draw it out in around something like that. So now I'm going to need some points to help me with my bisector. And again, you would use your compass for this. I'm going to use a circle because I don't have a compass. I stick my pointy point here, and I draw a circle out to the side. And I have a point that I want to put there. So I'll mark that. And my circle hits at two places, so I'll mark both of those points. And I'll label those. And so now we've got points D and E. So if I take all these points that I've got right now, and I ask them just to be hidden, I've got basically what I started off with in my last one. I've got a line segment. And how did we cut that into half? Well, we did it with two circles. We're going to do the exact same thing again. So I'll put all those lines back again just so that we can see them. So there they are. I'm going to do the exact same thing I did last time. I'm going to take my compass with my pointy end here and draw a circle over to the other point. I'm going to take a circle with my pointy end here and draw a circle over to my other point. And where the 2 points meet, I'm going to put a mark. Now you'll notice that there's 2 points meet down here as well. And when I join those together with a line segment, or we'll do a line, I go from here through here. It also goes through my center point here at the bottom. And so now what I've done, I've created an angle bisector by drawing that blue line down through the middle. So I'll take some of these extra pieces out of the way so we can see what we're doing. And there we can see it. And I'll ask the computer to measure this angle down here from E to B to this point up here. So I'll label it first and have the computer measure. And there it is at 24.62. And I'll also ask it to measure the other side. And we can see that both the angles EBF and FBD are both 24.62. And if I was to make my diagram larger or change it in any way, if I want to make my points further apart, I can see that my measurement of my angles will still be the same. And I've cut this same angle, 49.7 degrees, into two equal sized pieces. So now I've done an angle bisector. My angle has been cut into two equal sized pieces, using the same principle of bisecting my segment. So up until now we've looked at making perpendicular things that are at 90-degree angles, and we've cut things in half. So now we're going to be looking at a parallel line segment, which is like a railway track. They go on and on and on, and they never meet. And how can we create two lines that will never ever meet? So I start off with this line going across the bottom, a horizontal line, just like my horizon. And I'm going to put a point someplace on this line that I want to make a line that also is going to go parallel to this one. So how do we go about making sure that it will be parallel? So the first thing I'm going to do, again, I'm going to use my compass, or in my case a circle, and I'm going to go a certain distance up this line. I'm going to draw my line, and I'm going to change that into a little less obvious circle. So what I've done is I've created a point A at a certain distance away. Now I'm going to take that same circle, and I'm going to just move it up and do the same thing here. So now I've got my compass from my pointy end to here, so I'm going to do the same circle up above. And so I've created another dot, a point B, which is the same distance above my point where I want to draw my line that my A was from my original line. So now I want to do another step in order to be able to find a point across here. So I want to find a point down here someplace. So what I'm going to do is I'm going to do the same thing I did before. I want to find a distance down to my original line, and I'm just going to duplicate the same thing down this way. So I'm going to draw my circle, or I'm going to use my compass to go down to that same point that's below. And then I'm going to do the same thing that happens here. So I'm going to do that right now. And so I created a circle that connected with my original. So I have this dotted line down here. And then I went up to this point here. So my compass is the same distance that I had it from A to this point. So I'm going to go B down to this point. So now all I have to do is I take my line tool and I connect this dot with this dot. And now I've created a line that's that's parallel to my original. So what I've done is I've made sure that I've done the same thing to this bottom point as I do to the top point. So I made a point A the same distance above, so a point B the same distance above. I wanted to make sure I had a point down here that's the same distance below my A, and I did the same thing down here. So I just used my compass to make sure that I was doing the same things to both sides. And now I can connect my line. So I've got my parallel lines, and I just want to make sure that we can see that if I turn it on an angle, they'll still be parallel. This dotted line here and this solid line here will still remain parallel no matter how I configure or change my picture. That's the nice thing about making my constructions. My construction allows me to do it in a variety of ways. All these lines will stay parallel. And if I construct it properly, I guarantee that I have parallel lines. So now I'm going to make an equilateral triangle. I'm going to construct an equilateral triangle. So I have a point here and a point here. And I want to make sure that I make my point up here that's exactly the same distance for all three sides. And how can we go about doing that? So I'm going to do that same idea with my compass. I'm going to take a circle and I'm going to point it out to the far point. I take my pointy end and draw it back to the far point. And where my 2 points meet, I put a dot. And now I can connect those pieces and make an equilateral triangle. And now I have an equilateral triangle where all three sides are the same length. And I'll have the computer measure those for us just so we're sure. And now I've got the computer measuring distance A to B, distance B to C, and distance C to A. They all come out to 3.18. And if I expand them, we can see, and I turn them around, we can see that they all come out to always equaling the same amount, small or large. We've created an equilateral triangle that works every single time. And finally, we'll build an isosceles triangle, and an isosceles triangle is unique. Instead of having three sides that are the same, it only has two sides that are the same. So I start off with a circle using my compass, and I put points anywhere on my circle. So I'll put one here and one here so that they're on my circle. And it's very important that they have to be on the circle. And now I can connect my lines to make my isosceles triangle from there to there, from here to here, and from here across. And there it is there. I'll get the computer to measure so we can notice some things. And we'll notice that two of the sides are the same length, but the third side isn't. And if I move things around, these two sides still stay the same, 2.94, but the third side isn't. And if I make my diagram larger, the two sides are still the same, but the third side isn't. So I've produced an isosceles triangle with two sides of my triangle always being the same, and the other side being different. The other really interesting thing about isosceles triangles are if two sides are the same, then two angles are going to be the same. So the angles opposite from the sides that are the same will have the same measurement. So I'll have the computer measure those for us to show that. And you can see that both angles, angle ABC and angle ACB, the two top corners, have the same measurement, 63. And if I slide them around, it doesn't matter. My lengths are still the same, 6.7, and my angles, 73.8 and 73.8. And so I've created an isosceles triangle where two sides are the same and two angles are the same. And which angles are they? They're the angles that are opposite the sides that are the same. And that's a characteristic of an isosceles triangle. And so we've constructed lots of different shapes and ideas around geometry just using a compass and a straight edge. The computer allows us to do it much faster, but I wanted to show you that you can do it with just those two items.